Blazor DevOps with Dan Roth.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes and a few announcements to get past. My latest book, .NET DevOps for Azure, is available. You can get it now at bit.ly/.NET DevOps book. That's bit.ly/DOTNET DevOps book. And the ebook at bit.ly/.NET DevOps ebook. And there's also a special offer for user group and conference leaders, or really anyone speaking at those community events. And for those in-person events, I'd love to send 2 copies of the book for you to give away. And to request those, you can go to bit.ly/.NET DevOps book for community. That's a little bit long, but spell out .NET, bit.ly/.NET DevOps book for community. And we'd love to send a couple copies for you to give away at those events. Now, the book is available now, even as the publishing company is finalizing it for distribution on Amazon and other places. And I'm working on a .NET Core 3 edition to put out at the end of the year as well. So lots of work to do. But let's get on to the show. So my guest today, Daniel Roth, is a program manager on the ASP.NET team at Microsoft. He works on building frameworks for web developers, including ASP.NET Core and Blazor. Dan, welcome to the show, sir.
Thank you, Jeffrey. It's good to be here.
Absolutely. Man, you are all over the place. You're on Channel 9, you're speaking at conferences, and you're pretty pervasive. When do you sleep?
When I have to do one of those talks, I sleep very little. I've never been particularly good at preparing up front. I'm a bit of a procrastinator, so if I look a little blurry-eyed in some of those talks, that's probably why.
Yeah. Well, you've been at Microsoft quite a long time and done a lot of things. There's probably all the listeners have seen at least one of your talks, either virtually or in person. But what has your journey been, and how did you land on the ASP.NET team?
That's a great question. So I started at Microsoft actually straight out of college. I was a college hire. And when I joined Microsoft, it was on the .NET team. I joined on the system.NET team, like the networking team. And I still remember doing that because we would have these meetings with, do you remember MSN Messenger, like the old IM chat client? They were using .NET on their backend servers and all of the system.NET APIs and, having millions of users and stuff. And I remember sitting there as a new college hire talking to them, and I was like looking around, I'm supposed to own this? Like, I'm supposed to deal with this? This is incredible. And so I worked on networking. At the time, we were a part of actually the WCF team, like the Windows Communication Foundation team. They had sort of absorbed all things networking so they could build out, the services stack. So I worked on WCF for a good number of years on Service Util and SOAP and a lot of the serializers in .NET Framework I worked on in those days. I also dealt with ASP.NET web services, ASMX web services in that era. So I had a little bit of ASP.NET touch point there. It wasn't until later when I was working on WCF web API, like web API support in WCF, like support for HTTP services, RESTful services, that there was a transition that happened where a lot of the WCF team and the ASP.NET team kind of got reorged and merged together. And it was at that point that I got a chance to join the ASP.NET team and work on MVC. And the big project was actually building ASP.NET web API, like building a new web API stack for HTTP services that was aligned with ASP.NET. And that was super fun. And then since then, we've done all sorts of crazy things. I still remember Scott Hunter pulling me into his office and saying, Dan, we're going to we're going to take stuff and make it open source. And then my head exploded. I was like, open source. At the time, everything I did shipped in the .NET framework and was in Windows and was closed source and couldn't talk even about it to customers. And we moved MVC to be open source. We moved then to actually create an open source and cross-platform version of .NET with .NET Core. All that stuff happened after I got a chance to join the ASP.NET team. So it's been quite a ride. Yeah, I've been here a little while, a few years, and .NET just keeps getting better.
Well, we're on the cusp of a tectonic shift in how people write .NET applications. And I'm not sure people really know what's coming yet, but you're one of the leading program managers kind of figuring out what that new wave of programming model should be.
It's scary.
These are my words, but it's exciting. It's exciting. I mean, I remember the shift from the pre.NET technologies into .NET, and then 1.1.1 and then 2.0 and all the different shifts in between. And this is another one. This is another wave where we think WinForms, WPF, but Blazor could be the new desktop or native programming model as well, even though we're talking about web stuff.
Yeah, it's got I think a little bit of potential. I think it's got some future to it. When I started working on web frameworks with the ASP.NET team, most of the support we had for building web apps in ASP.NET was all about the server. Web forms, ASP.NET web pages, MVC, these are all server rendered technologies. You dynamically generate what you want to see in the browser on the server. And if you wanted to do something on the client, well, for many years, there just wasn't anything that you normally did. You maybe wrote a little bit of JavaScript, but a lot has shifted more towards the client side when you're building web apps. Frameworks like Angular, React, Vue, you're doing a lot more with the browser these days. And I have to admit, when I started working on .NET web frameworks, this was a bit of a concern. There's this shift to the client, and you couldn't run .NET code in the client. Well, there was this Silverlight thing, I think, for a little while, but that required a plugin, and that wasn't truly open web. It was more of an extension to your browser. And then this amazing thing happened, which is the web community got together and said, you know what, we should have a cross-platform standardized bytecode for the web.
One extension to rule them all. It's still kind of an extension. It's just, let's agree on what the extension is going to be, or the plugin is going to be.
Kind of, except instead of it being something you have to add to the browser and being proprietary, it's a W3C standard. It's spec'd out. WebAssembly, right? That's right. What really happened there. And
so we're already confusing people. We're already confusing people because you and I know what this thing is.
Yeah.
But the listeners are like, what do you mean?
What is WebAssembly?
And so, right. And why do we even need any new framework? I mean, what's the problem we're trying to solve? Let's start there.
Well, let's first, I guess, to motivate why this is all important. I think that shift to client-side development, moving your web app logic from server to client, I think that is actually fundamentally super important. You have the network, and there are two sides to the network, and there's a process on both sides with hardware and resources and things that you can do. You have, of course, your server resources, which with .NET you've always been able to take advantage of. But there's also a client process, with a machine and has a camera and storage and processor and stuff that you can do over there. If all you're doing is server side web app development, you're not taking advantage of that client-side process at all. And that client-side process has gotten super functional with HTML5 and all the new standards and the functionality that modern browsers now support. So client-side development in the browser, super important because it enables a whole bunch of rich interactivity and scenarios for your web apps that you just couldn't do before with just a purely server-side model. Now, WebAssembly, what that is it's a new bytecode, a low-level bytecode that's been standardized for the web. There's a spec on what this bytecode looks like, and all of the browsers have now implemented it. We used to say it's sort of a new experimental technology. It's not new anymore. This thing's been around for years. I think Google just announced that like Google Earth now has been ported to WebAssembly, so you can get super near native performance in the browser. With the Google Earth code base. AutoCAD is another one. AutoCAD's like a 3D rendering and design tool. They had their core engine was written in C and C++. They took that code, they compiled it to WebAssembly. You don't typically write code in WebAssembly. It's a compilation target. So you take like C or C+ code or whatever, as long as you can compile it to WebAssembly, it can now run in any browser, in any platform, mobile, desktop, at near native speeds. So the AutoCAD guys took their engine, compiled it to WebAssembly, and then boom, you've got AutoCAD Web, where you can now do design in a browser using the same engine that they were using for their desktop products. So when that happened, we looked at that and said, well, what if we could build a .NET runtime in WebAssembly? I mean, a .NET runtime, we typically write those actually in C and C++. They're usually written in native code. What if we could build a runtime and just have that run in the browser? Now you can run users' .NET code directly in the browser using a normal .NET runtime that just happens to be running on WebAssembly. That's what Blazor is all about, is enabling full, normal, open web technologies-based execution of .NET code in the browser, based on WebAssembly. So that's what we've been working on. It's been a lot of fun. Like a lot of developers that I talk to, they have had to live the pain of having to learn 2 different languages, 2 different frameworks, 2 different sets of tooling, 2 different build systems for both the JavaScript ecosystem and the .NET ecosystem. With a system like Blazor, you can just write .NET code full stack and leverage your skills for the entire application.
That's a huge challenge from a development team effectiveness perspective, having part of the app be a completely different development environment, the JavaScript ecosystem, and the other being a C#. And I think object relational mappers allowed more and more of the logic to be in C# because a previous generation's problem was, half this application's in SQL and stored procedures and all this, and then half of it is in C#. And how do we get more of it in C# so that our people can go faster, so that they're not jumping back and forth between these 2 completely different paradigms? And now we're doing it on the front end. It's awesome.
Yeah, and you get all these other benefits of being able to now share code. Like if you have 2 different languages and frameworks that you're using, well, let's say you want to do some validation logic, like you have a customer and you need to be able to validate that the name is there and stuff, stuff like that things are required. You would have to basically write that. You have to write that code twice today. You have to write it in the client side in JavaScript for the UI, and then you have to write it on the server again to actually enforce your business rules. With a system like Blazor, you can write a single library, like a normal .NET standard class library, and you can just reference it from both sides of the wire, on the client side and on the server. Use the same data annotation system, for example, that people have been using for years with .NET. You can take a customer type, annotate it with your data annotations, use that same type client side and server side, and now your validation rules are synced up. They're consistent without you having to do any additional work.
So this for WebAssembly, running C# in the browser is a new target that we haven't been able to do before. But what's the long-term vision for Blazor, even beyond the stuff that may be releasing this year? Because I mean, Steve Sanderson, I think at NDC has a recorded thing where he's kind of going over some of that, but it's a short period of time. What are you talking about internally?
So Blazor has actually evolved to be more than just, maybe we could get .NET running on WebAssembly. It's actually a broader application framework for writing UI, and writing UI for really anything. One of the beautiful things about the way Blazor works is, on top of that .NET runtime, we wrote a component model. And the component model is heavily inspired actually by a lot of the work that's been done by the JavaScript community on things like React and Angular. The components render HTML into an in-memory representation of the DOM. And then what Blazor does is it takes care of looking at what was rendered previously and what it was just rendered and doing a diff. And then Blazor actually takes care of applying the updated HTML content to the live DOM. And that's good for performance. But it's also good for this decoupling, because it means that you can now write these components that can render into an in-memory representation of what they want to show. And the application of that UI is done by something else. And it can even be done out of process. It can be done by a separate process. So you could imagine having all the Blazor components run in a web worker in the browser, and then have all the UI actually be updated on the UI thread, and that takes all the rendering logic off of the UI thread in the browser. That's pretty nice. Even more extreme, you can imagine taking those components and even moving them all the way to the server, and actually running your Blazor component server side, and then you set up a channel of communication with the browser using like SignalR, for example, or WebSocket connection. Now you can have all of the logic running server side, but all the UI applications happening client side in the browser. So like you click a button in the browser, it gets sent to the server. The component gets that event, it executes, it runs, it does its normal rendering thing. The UI diff gets sent back to the browser and applied. That's what we call a Blazor server side model, or a Blazor server app. And that's actually what we're shipping first. That's what's coming in .NET Core 3.0. We are shipping the component model and the server-side hosting model for Blazor apps. The reason why that's coming first is because it doesn't actually require the WebAssembly.NET runtime to be done. There's still quite a bit of work to make that runtime really good and production ready. It's not going to be ready in the 3.0 timeframe. We are working on it in parallel, but it's going to come sometime later. So first, we're going to ship the server-side hosting model for Blazor apps. Once the WebAssembly runtime is done, the same components can then be shifted to the other side of the wire and run directly in the browser on WebAssembly. That would be a Blazor WebAssembly app. Blazor WebAssembly apps then have all the normal characteristics of like a front-end JavaScript-based app. You can build progressive web apps with them. Like if you want to enable offline support, you can add a service worker, you can add the corresponding manifest file. Now you have a progressive web app implemented in .NET and C#. Progressive web apps can be installed directly on Windows or through the various app stores, so that they feel like you've now got a native application, but built with open web standards. You can even go a little bit further than that, though. Like, what if the Blazor components were actually, instead of talking to a browser, what if they were talking to Electron, like an Electron process, which is basically just a browser kind of wrapped up in a desktop application? Now you can build Blazor apps that actually are cross-platform desktop apps that have access to the native functionality of the OS, because Electron apps can call anything that they want in the underlying operating system. We have prototypes and samples that show that. In that setup, the Blazor components actually run in a normal .NET Core process. They're not using WebAssembly, and they just set up a little channel, an IPC channel with the Electron process, so you can build a cross-platform Electron app. And then I think even more interesting would be to do something similar with what the React guys have done with mobile, where you can take your React code and build a mobile application with React Native. What if you could take your Blazor code and build a native mobile application with, like, say, Xamarin as the .NET runtime, where the Blazor components, instead of rendering to HTML, they can render directly to native OS components like iOS controls or Android controls, or potentially you could even have them render to a web view and have full reuse of your UI by having like a hybrid model where your components run and render into the web view using HTML. That entire spectrum of scenarios, from server side, client side in the browser on WebAssembly, PWAs, cross-platform desktop apps, mobile, are all things that are possible with this Blazor application model.
Okay, that is a lot. And you answered, it's not coupled to HTML even, because if you mentioned Xamarin, now we're talking native iOS controls.
Yeah, the rendering layer in Blazor is not coupled to HTML. It can actually be replumbed to render to something else. One of the demos that Steve Sanderson showed in that NDC Oslo talk, which is a great talk, if you haven't seen it, you should definitely go check it out, is he took Blazor and wrote a bunch of Blazor components that render to Flutter components instead of HTML. He called it Bludder, Blazor plus Flutter. So he showed writing a Flutter apps typically are written in Dart. which not the most extensively known language. I mean, I maybe
not too many people do a whole lot of programming Dart.
Super familiar with the Dart language, but by using Blazor, you were able to write a Flutter app in C# using the Flutter UI components and their underlying pixel stack. So it's very flexible model. It doesn't have to be HTML. It can be some other rendering stack underneath as well.
The Azure DevOps podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Has the architecture and design process already started in conjunction with the Xamarin team?
We have had those early conversations. They are really excited to do a collaboration on Xamarin and Blazor. Not a lot of work has been done on the actual implementation yet, and the reason for that is, well, that spectrum is quite a lot of work. Like right now, we're almost entirely focused on .NET Core 3.0, getting the Blazor component model done, shipping the server-side Blazor model by the end of this year. That will ship in September. So in September, you can start using that model right away. Next step, I think, is what we'll do. We'll focus on the WebAssembly support and getting that done so that you can have a real full client-side support for running .NET in the browser. So that'll come sometime later. We did announce that in .NET 5, which is like this alignment of .NET Core and Mono, that WebAssembly will be part of that. That's scheduled to ship a little bit further out, like November of 2020. We hope to have something for Blazor on WebAssembly earlier than that, but at least that gives us a goalpost about it. It won't be any later than that. So WebAssembly will be next, and then mobile or desktop. I'm kind of leaning more right now towards trying to go chase mobile. We'll probably have proof of concepts going on that space earlier, but it's just a lot of stuff to do, and we're working our way through it.
Okay, and I think you guys have already announced that .NET 5 is going to be the reconvergence where we'll stop saying .NET Core anything. That .NET Core kind of will be .NET 5, but all of the stuff that needed to be pulled over, or the paradigms from .NET Framework, will have been done at that point, right?
Yeah, most of this stuff, we think we've got enough stuff in .NET Core now that we can make it sort of the main train going forward. Now, it doesn't mean that .NET Framework's going away. .NET Framework 4.x, whatever version they're on now, will continue to be in Windows, continue to be supported for the foreseeable futures. No end of life plans there as far as I know. So if you have a .NET Framework app, rest assured that you will continue to be supported. But for the innovation train going forward, .NET Core is where we think we have the most flexibility to add new features, to change things, to enable scenarios. It's the cross-platform stack. It's the open source stack. So .NET Core vNext essentially becomes .NET 5, and we'll do a bunch of convergence also with the Mono folks on their runtime, so that we really we're back to one .NET again instead of having to talk about all these different runtimes.
So let's do a quick run through of what the DevOps environment looks like for a Blazor server-side app, because that's what we'll be shipping later on this year and people can actually use first. Just so people get an understanding of, okay, well, how do I set this up? Let's just go from developer's workstation all the way through the whole process to running it in production and supporting it, and just to explore, okay, what's that going to look like for people?
Yeah.
So on the workstation, what do people have to have installed in order just to have it running locally first?
So all you need for Blazor server apps is .NET Core 3.0. You're going to need the latest version of .NET Core that we're working on right now. That will ship in September, but we have previews out that you can try out right now. So go to .NET and install .NET Core 3.0. That's enough to then create a Blazor server app. For the tooling on Windows, you want to get the latest preview version of Visual Studio. So Visual Studio 2019, the preview channel. Go to visualstudio.com/preview and install that channel. That has all the tooling you need for working with Blazor components, using the Razor syntax, getting great completions around the component elements and so forth. So if you want VS, make sure you get the preview channel. That's important. But .NET Core 3.0 as a runtime and SDK, that's all you need. If you're on a Mac or on Linux, I would recommend getting Visual Studio Code and installing the C# extension. The C# extension does have support for working with Blazor applications and Blazor projects, including all the Razor IntelliSense features. So that'll help you out there. So those are the things that you'll need to get set up on your machine.
All right, so in source control, and I'm just going to assume all of our listeners are going to be using Azure repos with Git repository or GitHub. And so what's going to be different as they store their code? And we have a new file extension, but how is that solution structure going to look like? And what kind of files are they going to see in source control?
So Blazor server apps are just normally a single project. I mean, they can have as many dependency projects as you want, just like you would with any .NET Core or ASP.NET Core app. The Blazor server app is an ASP.NET Core project. The things that will be different about it is, like you said, there is a new file with a file extension that you use for authoring your Blazor components. It's a .razor file. A .razor file really is pretty much a .cshtml file, but we compile it in a different way. CSHTML files get turned into pages and views for MVC or Razor pages, whereas a .razor file we're actually compiling into this new Blazor component model. It captures the full structure of the HTML under the covers, so it can do that fancy DOM diffing algorithm that I described earlier. So when you look at the project, it'll look the same as any other ASP.NET Core project. It'll have a startup file. It'll have a www root folder for your static assets. But you'll have a bunch of .razor files instead of .cshtml files for your components. And then any other .NET standard class libraries that you want to reference, any NuGet packages that you want to reference, that all works as normal.
And if someone has an existing ASP.NET Core web application already going, would they be able to make one page or one route, one URL, Blazor enabled?
Absolutely. Yes. You can integrate the two. In fact, the default Blazor server app template is already a mixture of both server-side rendering and client-side UI logic using Blazor. One of the things that you often want with a client-side app is you want to be able to pre-render the app on the first request. So like you make the request to the app, you'd like the HTML for the app to come to you right away, as opposed to having to wait to set up a WebSocket connection to the server and have the server do some rendering stuff and then send the DOM through the WebSocket connection and render. Because you need things like search engine optimization. You want the first render to be as fast as possible. So we call that pre-rendering of the app. The pre-rendering of a Blazor server app is done using these same technologies we've had for server-side rendering forever. You have a Razor page sitting in the app that renders the components for the initial render, and then client-side we set up the WebSocket connection and reattach to that state. If you have an existing app, you can have some of your pages be Razor pages and MVC views, and some of your pages then be client-side UI effectively with the new Blazor model. You can actually even have little islands of interactive functionality in your pages and views. Like maybe you have a page, but you have like a widget that you want to be interactive and just want to put in a Blazor component right there. There are HTML helpers that you can call that will set up a Blazor component inside your pages and views and then wire them up for interactivity using the WebSocket connection.
Oh,
so
sweet.
You can absolutely mix and integrate the two. One does not supersede the other. I think a lot of people sometimes assume that because we built a new thing, that means I got to throw out my old stuff.
Okay.
No. Like that. There's two ends to the wire. MVC and Razor pages is for the server side part of the wire. Blazor is for the client UI piece. Like all that stuff that you used to have to add some JavaScript to deal with, that's what Blazor is for. You still keep the server side rendering stuff as well.
So same project type then? For CS Proj, it's the same project type GUID that Visual Studio interprets, or different?
It's still a CS Proj. It's still an ASP.NET Core project. I believe the project GUID is the project type is the same. You're targeting .NET Core App 3.0, so you're targeting .NET Core. You're using the normal Web SDK, the MS Build Web SDK for your ASP.NET Core project. All that stuff is the same.
Okay.
The only things that are different is that you have a bunch of Razor files and you have a little bit of startup code to set up to set up the hub that's going to handle the WebSocket connection from the browser, and then you have a host page, a Razor page that has the bootstrapping JavaScript code that's used to set up that WebSocket connection and get Blazor up and going.
Okay. All right. So from from a private build perspective, before someone commits for the next step in our DevOps process, if they want to run unit tests and component level integration tests, is anything different if they're using in-unit or if they're using X-unit? Is anything different for the Blazor framework in that regards?
I think the main thing that's going to be different is for testing the app. Let's say you want to do integration tests. Well, the integration is all happening over a SignalR connection. So any requests that you want to send to the app, you can't just create an HTTP client and start sending requests to the components. You need to have the WebSocket connection set up, and you're going to need to somehow simulate the events that would be sent by the browser to the server and to execute the components. If you wanted to do an end-to-end integration tests. For unit testing, you probably want some way of taking your components and newing them up, giving them some of their parameters, and testing their rendering logic to make sure that they're doing the right thing. That is something that you can do today. The rendering output will be given to you as a fairly low-level abstraction. It's this render tree abstraction, which isn't great, honestly, right now. So it's a little tough to do it. We do plan to give you test helpers to make unit testing your individual components much easier. That's not actually going to land in 3.0, unfortunately. So initially, people will have to sort of struggle through that. We'll give you docs and samples. But certainly after 3.0, we also plan to add a bunch of test support to make unit testing your components super easy. It should be as easy as testing like a controller.
Okay.
You should be able to new them up and just execute them.
Now, the .razor files are not controllers, right?
No. They're components.
So for Blazor, they're components, right? But the .razor file, I kind of think of as the view. So with Blazor, do we have the view controller pair?
So the component owns all of its rendering logic. So it is view in the sense that it is a UI abstraction. The code that you write in that .razor file is all about handling the user events and deciding what you want the render output to be. Now, there can be some people look at the .razor files and often the pattern we use in our templates is there's a code block at the bottom that defines all your event handlers and your component state and any parameters that the component takes. So it's all in one file normally. Some people like to take that code and pull it out into a code behind file. And you can do that. The pattern that you use today is you basically define a base class for your component, like a component base. And you put all the event handlers and the parameters and stuff there. And then in your Razor file, you just inherit from that class. And that allows you to pull in all that logic and have it be in a separate C# file. It's just mostly a factoring thing. It doesn't really change the functionality. But some people prefer to have a little bit more separation between the C# code and the markup logic that is in the Razor component file.
So because ASP.NET looks at these .razor files as a component, that's all the ASP.NET framework cares about. If you want to do a controller or use a controller pattern or presenter pattern, that's just regular C# class and you're on your own, go to town.
Exactly.
The framework doesn't care how you factor out that other code. It's just regular old C# classes.
Yeah, if you want to have some sort of centralized piece of logic that's handling all of the user inputs, so that the a component event comes in, you click a button and you want that to go to some other class that's going to kind of orchestrate all of the interactions for your application. You can do that. It's not a prescribed pattern by the component model. It's up to you to do what you'd like. And a lot of people have been experimenting with that, trying different things. Like if you like MVVM, there are people who have built MVVM support on top of the Blazor component model. If you like the Redux or Flux style app state patterns from the JavaScript world, there are people who have done ports of those state container style patterns on top of Blazor. Our philosophy is we don't want to be too opinionated with Blazor. We're trying to be more like it's more like React, in that React gave you the underlying component model and then sort of let the ecosystem and the community innovate and decide what they thought was best on top of it. We're very much trying to have a Blazor be a community-based stack, as opposed to something where Microsoft comes in and prescribes this is how we think we do everything.
Okay. So for full system testing on a completely deployed environment, is Selenium compatible just by default? Or are these regular HTML DOM elements that one would just type into and then click on buttons, or is there anything special to get those full system testing frameworks hooked up?
So I believe we actually are using Selenium in our own integration tests that we use for Blazor. So yes, you can absolutely use Selenium. I would point you to our GitHub repo, to the ASP.NET Core repo and the ASP.NET org to take a look at how we set those things up. Like I said, the checking the DOM elements, that will all be the same because it is just normal DOM. The only place that's going to be a little different than a standard request reply style web application is that you're dealing with all the interactions over this WebSocket channel. So it's more like trying to do integration testing for a SignalR hub or something like that you'll have to do.
Okay, so I think, is that github.com/ASP.NET/Blazor?
No, actually it's ASP.NET/ASP.NET Core. That's where you want to look. We do have a Blazor repo that's still out there in public. That's where we initially started Blazor as an experimental project.
Okay.
It was a thing we weren't even sure if it was going to see the light of day. Would anyone want this? Does this even work? And so that's what the Blazor repo was all about. We still use it for some infrastructure things, but all the main Blazor development is now happening in the main ASP.NET Core repo.
So truly not something different, just part of ASP.NET Core.
Exactly.
So github.com/ASP.NET/ASP.NET Core.
Yep.
Got it. All right. Okay. So now we're just deploying on, what are our deployment options? I feel like you're saying, oh, it's just ASP.NET Core. Is there anything different? Now let's jump straight to Azure PaaS. If I'm going to enable one of my ASP.NET Core on .NET 3 preview, but .NET Core regular down the road, what do I need to do to get it working on Azure PaaS services? Okay,
so to run a server-side Blazor application on Azure, you're going to need a couple of things. You're going to need, first of all, .NET Core 3.0. Right now, .NET Core 3.0 is in preview, so it hasn't been deployed to, like if you're running in an Azure app service or something like that.
It's not a few extra steps.
It's not there, so you have a couple options. You can deploy your app as a self-contained application. What that means is that it will bring the runtime with it. So the payload's larger. You just sort of bring the runtime along with your app. Another option is to use a site extension that we provide that adds .NET Core 3.0 previews to your Azure App Service. That's an option you can do. There was an issue with Preview 6 where the site extension, we had updated it to use SemVer v2, and Azure App Service had an older version of NuGet, and so it wasn't working in Preview 6. But that'll be fixed in the upcoming Preview 7 pre-release. So if you're using Preview 6 bits right now, you'll probably want to go the self-contained route. In the future, we will be deploying .NET Core 3.0 to Azure, so it'll just be there and you won't have to worry about it. Now, other things that you'll need on top of that, well, you need, most of the time you're going to be operating over a WebSocket connection. So you'll need to be able to enable WebSocket support. Also, because it's a stateful model, you'll need to enable server affinity. Like you'll want connections to stay on that server. And so load balance around, and then the state that your client was using is no longer on the server that it's connected to, those types of problems. So you need to turn on those features. But doing it directly to Azure App Service is actually a configuration I would shy away from. A better way to set up your app will actually be to use the Azure SignalR service to handle a whole bunch of concerns for you. The Azure SignalR service will handle connection scale out for any SignalR-based app, including Blazor server-side based applications. Remember, every client that's going to try to use your Blazor server app needs to have its own connection in order to work. And being able to handle, 10,000 or more concurrent connections can be a tricky scale-up problem to solve. The Azure SignalR service just handles that for you, and then it multiplexes the connections back to your app service without you having to worry about anything. You just slide a slider to say, I need to be able to handle more connected clients, and it'll just deal with it. It also will handle the server affinity problems for you, so you don't have to deal with, configuring the AIR server affinity. So that's a really nice setup. And in fact, we've added some tooling support in Visual Studio that if you publish your app to an Azure App Service, it will recommend to you, hey, if this is a Blazor server app, you really should use the Azure SignalR service. You'll have a better experience, and you can just add it as a dependency. It will take care of adding a NuGet package to your app, and you don't have to touch a line of code, and it will configure it on Azure so that it just lights up. So just add Azure SignalR service as a dependency in the publish workflow, and then you should be good to go.
Is this in addition to the web app, or is it replace the need?
You need both. So you'll deploy your ASP.NET Core app to Azure App Service. That will host the app. And then for handling connection scale out and affinity, you set up the Azure SignalR service with that app. And what happens when clients connect, like they'll initially send a request to the Azure App Service. They'll try to set up the WebSocket connection. The NuGet package that gets added, the Azure SignalR Service SDK, will see that connection come in, and it will basically bounce it. It'll redirect it and say, instead of connecting directly to the app service, why don't you go connect to the Azure SignalR Service? You'll be better off. And so the client will then connect over there. The Azure SignalR Service will then get a connection from the app service to it, which it then can use to multiplex all of the communication from the client to your server. And it'll handle server affinity and lots and lots of client connections without you having to sweat it.
Okay, so for low-scale dev and test pre-production environments, I think a lot of developers are used to just using the Azure App Service, and on the free tier, it's like, yeah, it's having so few things, it's pretty much free. When setting it up this way for low traffic, is the SignalR service have the free tier enabled as well?
They also have a free offering that you can use. The exact pricing details are escaping me right now. So at what point it becomes a paid offering, I honestly don't remember.
Okay, it's not one of those expensive ones.
And free things, Jeffrey. I know Azure pays the bills, but most of the stuff I do, you can just use and copy to your heart's content. Yeah, I would check the site on what their pricing model is, but they do have a free offering that you can try out and experiment with.
Okay, awesome. And because it's just ASP.NET Core, all the same telemetry stuff with App Insights should work the same as well.
It will, but the things that we actually need to do some work there to make it even better, like a lot of the page navigations and things that are happening in your app are now happening all at the Blazor level, right? And an app service doesn't actually currently have a lot of instrumentation to see what's going on there. They will see, of course, all the log output and all the normal telemetry output that comes out of ASP.NET Core, but we envision a world where actually Azure App Service has some really deep integrations with Blazor. Even when if you decide to run client-side on WebAssembly, you can imagine doing something there as well, and that would enable you to get great diagnostics and telemetry on your applications. That's work on our side that we still need to iron out. Okay.
Wow, this is a lot of information, but the future is certainly bright. Before we go, is there any additional resources that you would encourage the listeners to follow up on if they want to learn more?
Yeah, go to blazor.net. hbs:/blazor.net. That's where you can get started with Blazor today. It's super easy to get started with. You can get going in probably about 5 minutes, build your first Blazor app, and maybe never have to write JavaScript again. It's just all .NET from here on out.
We can dream. So, all right. Well, awesome. Man, thanks so much, Dan, for being with me and sharing your time. I appreciate it.
Oh, it's my pleasure. Thanks for having me on the show.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.